Hi, everyone. I'm Brett Rudenstein. I'm Vice President of Solutions Architecture for Vantic. I've been with the company now for about a little over 7 years, and I've spent a great deal of my time in various forms of application lifecycle management, stream processing, and big data. And Vantic, interestingly enough, is an interesting culmination of taking all of those different disciplines and putting them into this orchestration platform. So what I'm going to show you today is a couple of different demonstrations of things that have been built with Vantic. And generally speaking, these applications, which are full applications, they run, they've been put together by usually 1.5 engineers in a 2 or 3 week time span, each one of them. And so it's a rapid platform for not just building prototypes, but as Jim talked about, those prototypes inherit those mission critical capabilities. So what is Vantic? Vantic is a platform that sits at the intersection of streaming sources, other systems, and the people that interact with them, and now specifically generative AI. And we're going to cover a number of generative AI use cases. This first demonstration is going to be a use case, a medical use case around ARDS, or acute respiratory distress syndrome. We're going to see a smart hospital that works with generative AI to produce better outcomes for patients. One of the first things I'm going to show you here on the screen is this flow diagram. And this is actually one of the application building tools inside the Vantic platform. Everyone's been talking about Jarvis practically since the beginning of this conference. This flow diagram is the fundamental basis for the 2 demos that you'll see, which is not Jarvis. One of them is Ava, and one of them is Samantha. We'll get into what those mean, just like Jarvis is an acronym. But this is the building blocks within the platform, the low-code platform that allow you to rapidly put together these kinds of situational awareness. So the first thing that you're looking at on screen is this smart hospital dashboard that's looking or constantly looking for updates from Vantic's real-time engine. And the real-time engine is listening for streams of data. Some of those streams of data are coming from ventilators. We'll get into that part of the demonstration in a minute. Others are coming from physiological devices, looking at heart rate variability, blood oxygen, and things of that nature. But just as important as the real-time streaming data, it's also listening for the data that's not coming in. And so one of the things that you just saw pop up on the screen is an alert suggesting that there's a piece of missing data. So one of our patients has maybe been accidentally disconnected from the data. Perhaps they pulled off a lead. Something has occurred, and we need to immediately find the right person with the right skill set and the right georadius, who's on call. All those things have to be contextualized. And so Jim used this phrase. He said, so what? There's a dog, there's a cat. There's a big so what moment, and you have to be able to not just get an alert, but very specifically arrive at specific business outcomes. In a business context, it's a business outcome like Uber. In a military context, that's a mission outcome. And in a hospital or a patient context, that's a patient outcome. And what's interesting about systems like these is they're asynchronous in nature. There's no prescribed order for what order these things are going to happen in. So you have to be able to take the next best real-time action in order to triage and actually get you closer. Well, let's see another event that's going to come in here in just a moment. So the next thing that's popped up on the screen is we see that we've got a patient who's now showing an elevated clinical risk score. We won't get into the details of what the medical stuff underneath the covers is. What's important is that Vantic has contextualized a set of real-time data and through a set of algorithms running in the Vantic backend, determine that this patient now runs a clinical risk. In this case, her blood oxygen has dropped, her respiration's gone way up. And so the system has sent a notification. It's also the first time that we'll see some introspection of generative AI. So one of the things that we can do is we can actually click on this patient and pull up some of that information. We can see that the reason she got that clinical risk score was because of those specific values. Again, Vantic contextualized all that into the situation of interest. The next thing that we can do, though, is the system automatically generates prompts. And so what we've seen here in this case is in real time, when that clinical risk was assessed and got that warning score, it also dynamically generated a prompt into the environment. The prompt was, here's all the patient's information. So it pulled from the emergency medical record. It pulled her current information, current vitals, current statistics, and said, based on this clinical risk assessment, What are the appropriate next steps? Now, this is where things like trustworthiness come in. And so this is where we've done a couple of interesting things. I think one of the things that's sort of tricky when it comes to creating that Jarvis-like functionality is sometimes when you talk to an LLM, you want to, or a large language model, you want to ask a question. Sometimes you want it to be a command or an action. You saw Tony doing that throughout that entire video interaction. How do you get all those things to happen when you might need 4 or 5 different AI engines, foundation models, large language models to pull that off? And so in this particular case, what we have is the use of a retrieval augmented generation, or what is commonly called RAG. In very simple terms, this simply means I only want to pull information from a finite set of documentation that we trust, give that to the language model to contextualize and to a level of semantic understanding that we can look at and take a next best action on. Of course, we also want to know where that came from. So what we'll also do is take the information and we'll give you the ability to go directly into the referenced material. So here what you see is it actually said, well, these are the PDF documents where all of that information was coming from. So it's also the ability to not just trust the information that the system came back with, but also the ability to verify that information. Dr. Ryan Vega, who's in the back, our chief medical officer, when he modeled this patient's sort of simulated data, he modeled it after pneumonia. I find it interesting that the very first search result that came back from the system was community-acquired pneumonia. So it's very good at contextualizing those things and pulling those things back. All right, but now let's kind of get a little bit further into that Tony Stark-like Jarvis, and I'm going to introduce you to Ava. So what you'll see here in just a moment is the system is also looking at real-time information coming from the patient's ventilator. And what you just saw pop up on my screen is a notification that one of our patient's ventilators is not in its optimal setting. So what did Vantic do behind the covers to do this? What it did is it took in the real-time ventilator information and noticed that there was a recent blood gas analysis from the labs, combined those to generate what's called the Berlin score, which simply rates the patient, their level of acute respiratory distress. It's a moderate, medium, or mild. So forgetting the medical stuff underneath the covers, the system generated that. But then what it did is it said, are these the optimal settings for this particular patient? And when it looked that up, once again, it automatically generates a prompt, sends it to the LLM using a regenerative lookup. It does that and then brings that information to the doctor's attention. So Ava is the automated ventilator assistant. You can see our patient, Kenneth, here has been identified with non-optimal settings based on the current blood gas analysis. And so now it's going to give us the retrieval information. And if you look at the information, what it effectively says is, I've looked at this data, I've seen that this patient isn't utilizing the proper ventilator settings, and here's what I recommend. Now this comes to that point about trust. Once again, there are thousands of pages. In this particular case, the manuals and the data that we use are specifically a PDF called The Mechanicals of Ventilation. This is material that we license, or not we, but the hospital would license to be able to trust and verify that data. So we've got that, but we also want to be able to create those interactions. Very much like you saw the PDF before, I want to start issuing commands. And so I can say something like, I look at the information, I tend to agree with it, but I'll say something like, show me the PDF for the referenced material. And so what the system will do is it will look at that information, sends it off to the LLM. The LLM now has to do some complex interactions. And this is one of the things, when I showed you that flow chart at the beginning, that diagram, the tool that we use to build these applications, well, there's actually 5 different large language models in use here. One of them is using for a very minor form of what's called prompt refinement. And all it does is makes a simple decision. Are you asking a question, and should I send this to a search engine for pulling out that semantic relevant search? Are you issuing a statement? Is this something I should record in the index? Are you issuing a command? Is this something that should go off to an LLM that's good at basically executing functions? Or maybe just issue it off to a natural language processor? And so in this particular case, if you look at the mobile interface here, you can see it's brought up the essentials of mechanical ventilation. And if I click on that, it'll go into that document, go to the page where it was referenced, and I now have all of that referenceable material. So, okay. So now that we've seen that we've got that information, we want to start interacting with the LLM, and we want to start giving some specific commands. So maybe I want to see what the patient's current ventilator settings are. I'll say something like, let's do, show me the current ventilator settings for the patient. So once again, it goes down that decisioning process, not a question in this particular case, it's a command, and then brings up all the ventilator settings. So now I have this contextual information. Let's bring these up. I'm going to bring these up in the main dashboard over here. And so in the main dashboard, we'll see it because now I want to give instructions as to actually make a change in those outcomes. So our patient's currently in pressure support mode. They've got various settings. I'm going to ask the LLM to go ahead, and I'll ask Ava to make those changes. I'll say something like, modify the patient's ventilator settings based on your recommendation from above. And so you'll notice that the mode will change, the PEEP value, the title value, all of those things will change in real time per my instruction. Now, this might seem a little bit too futuristic in trusting the interaction to directly modify the ventilator. So what might be more appropriate is saying something like, ask the respiratory therapist to go modify these ventilator settings. And when the system doesn't have enough contextual information to do it, in this case it says, sure, I'll do that, but who's the respiratory therapist? Or it'll look at that information up and so forth. So this is one of the ways that we take Vantic and orchestrate those complex interactions between multiple LLMs. There's one more thing that I should mention here. When we were doing those retrievals, we talked about the ability to reduce hallucinations. And we talked earlier about one of the patents that we've submitted relative to reducing those hallucinations. One of the things that happened was not only a retrieval search, but also it sent it off to multiple language models for a consensus. Each language model receives the same prompt and the same information, generates a response, because what generative AI is good at doing is actually generating something from very little or nothing, whether that's text, video, image, or otherwise. But then we send it, so from those two LLMs, we send it to a third and say, do these agree? And if they agree, we'll take that agreement, look at a similarity search, combine the answers, and then provide the result. This is what it means to rapidly build production-level applications at unprecedented speeds.